Welcome to A-Level and AP Physics. In today's lesson, we will discuss a typical type of question on medical imaging from March 2021, paper 4, variant 2. In this question, we will discuss some very important points about X-rays. If you're struggling with X-rays and you're always stuck with questions on this topic, then watch this video carefully, and after watching this video carefully, you will be able to handle questions on X-rays with confidence. For question number 11, part A, it is given to us: electrons are accelerated through a potential difference of 15 kilovolts. The electrons collide with a metal target and a spectrum of X-rays is produced. For part A1, we need to explain why a continuous spectrum of energies of X-ray photons is produced. First of all, let's try to understand production of X-rays. So I will write on here how X-rays are produced. Production of X-rays. In order to produce X-rays, first of all, we need to emit electrons. So the first step is electrons emission. We need electrons. So simply we can say the step one is electrons emission. And these electrons, they are emitted by thermionic emission. So we can write down these electrons are emitted by thermionic emission. Thermionic emission means that cathode is heated. When cathode is heated, electrons are emitted. You can see here, in this case, we have cathode filament. When we heat up this one, by applying potential difference across the heater, electrons are emitted. So that is called thermionic emission. Emission due to heat. So thermionic emission simply means that emission of electrons due to heat, or by heat, we can say. Emission of electrons due to heat. This is called thermionic emission. And the second step, these electrons means the electrons emitted due to thermionic emission, those electrons are accelerated by potential difference. And so electrons are accelerated. So those electrons, we accelerate them by applying potential difference. So this is the potential difference you can see here between these two terminals. So we have 0 volts here and we have 100 kilovolts here. So due to this potential difference, electrons will be accelerated. Means electrons, they will gain kinetic energy. Accelerated electrons mean electrons are accelerated by PD, potential difference. So this is our cathode and this one is anode. So electrons are accelerated. When these electrons are accelerated, they gain kinetic energy. Means electrical energy become kinetic energy of electrons. So gain kinetic energy. And when these electrons, they hit the metal target, metal target. When they hit metal target, metal we use is tungsten. So the metal used for X-rays is tungsten. So this is our metal target. You can see this is. And this is made of tungsten. So this is metal target. And this one is made of tungsten. And this anode is rotating. Because if electron is at one point all the time, temperature will be very high. So this anode will melt. So one of the reasons we use tungsten metal is it has high melting point. And also we cool this one by circulating water here or any other fluid. So this anode is rotating. How we cool this one? By water and by rotating. So electrons don't hit one point all the time. As these electrons, they hit metal target, electrons decelerate. So we can say electrons decelerate. Decelerate means they lose kinetic energy. They lose Ke. And this lost Ke become energy of photon. So this become energy of X-ray photon. So this become energy of X-ray photon. And the energy of X-ray photon is equal to delta Ke. It simply means that this is equal to initial kinetic energy of electron minus final kinetic energy of electron. The difference between kinetic energies of electrons become energy of X-ray photons. So this is what you need to understand about production of X-rays. So this is how X-ray photons are produced. Let's try to understand this one with the help of one simple figure. I have already drawn for you here. So I will clean this part a little bit and I will explain you what is happening here. In this case, you can see we have incident electron. So this one is incident electron. It has certain amount of kinetic energy. So it has certain amount of kinetic energy. So incident electron, it has energy EKI. So we can say it has energy EKI. And when it approaches closer to the tungsten atom, this electron will decelerate because there is an attraction between electron and nucleus. So this will decelerate. So when this will decelerate, it will lose kinetic energy, and that energy becomes energy of X-ray photon. So after this one, the energy of electron has decreased. So this one is the final kinetic energy of electron. So the energy of X-ray photon, we can say energy of photon, this is equal to change in kinetic energy of electron, or simply we can say this is KE initial minus KE final. That's all what we need to understand about production of X-rays. And different electrons, they decelerate by different amounts. For example, if one electron, for example, is passing through this point, means is far away from the nucleus. So this one may decelerate by a little amount. So the photon, X-ray photon produced due to deceleration of this electron will have less energy because it will lose less amount of kinetic energy. Different X-ray photon, they have different amount of energy because they decelerate by different amounts. That's all what we need to understand about production of X-rays. I hope that it is clear to you. Now let me show you the answer, how you can write down a proper answer. This is how you can write down a proper answer. In your answer, you have to mention as the incident electrons pass close to the nucleus of an atom, electrons will decelerate. If you write down the electrons will decelerate, you will get 1 mark, and this one is B mark. And they decelerate by different amounts. So they have range of deceleration. So you will get the second B mark. Excess energy is given off as X-rays. So X-ray photons will have continuous range of wavelengths. And continuous range, this depends on amount of deceleration. So if you write down this one, amount of deceleration, you will get third B mark. Amount of deceleration, you will get third mark. So this is how marks will be awarded for this part. For the second part, we need to calculate the wavelength of the highest energy X-ray photon produced. In the last part, we have already discussed X-ray photons are produced with different amount of energies. And energy of X-ray photon depends on amount of deceleration of electrons. In X-ray production, electrons are decelerated by different amounts. They have range of decelerations. And X-ray photons, they have range of energies. So let's try to understand energy of single photon again. Energy of photon, single photon means X-ray photon produced is equal to change in kinetic energy of electron. Or we can simply say this is equal to loss in kinetic energy of electron. So we are using symbol small e for electron. And other way to write this one is we can say this is equal to kinetic energy, means the initial kinetic energy of electron minus final kinetic energy of electron. We need maximum energy. We want to give maximum energy to photon. So E of photon, when this will be maximum. So E of photon, this will be maximum when KE final, this is equal to 0. So energy of the photon is maximum when KE final is equal to 0. Means electron just simply stop. So in this case, we can say energy of photon, here I will be writing here, maximum energy of photon, photon energy maximum. This is equal to kinetic energy, initial kinetic energy of electron. So this is equal to initial kinetic energy of electron. Then initial kinetic energy of electron is equal to work done by PD. So this is equal to work done by potential difference, or we can simply say electrical energy supplied. So we can also write down this is equal to electrical energy supplied by PD. Electrical energy supplied. So this is electrical energy supplied to accelerate electrons. Now simply we can write down energy of photon. This is equal to hc over lambda, and work done by potential difference, this is equal to q times delta v. So this is q times delta v. We need to calculate lambda. So this is lambda minimum value. Lambda min means the lambda is minimum, it means energy of photon is maximum. So this is minimum value of lambda, and this minimum value of lambda later we will discuss. This is also called cut-off value. So cut-off value. So this is also called cut-off value. You need to calculate lambda. So in this case we can simply write down hc. This is equal to lambda min minimum times q times delta v. Q is the charge on electron. We need lambda minimum will be equal to hc over q times delta v. Delta v is the potential difference. H is a Planck's constant, so we can write down its value. You can also get this one from the data list, and this is equal to 10 to negative 34. C is a constant, 3 times 10 to 8. Value of this one is also given, and we have Q is the charge on single electron, means elementary charge. This is 10 to negative 19 coulombs, and we have potential difference which is given to us, that is equal to 15 kilovolts. So we have to multiply with 1000. Now if we simplify this one, our answer is going to be 8.29 times 10 to negative 11. But in our data we have least number of SF2, so it's better to write down our answer up to 2 SF. So we can say our final answer is 8.3 times 10 to negative 11. So this is final answer. This is how you need to calculate. It's simply kinetic energy final zero means electron just stop. So electron just stop. So electron just stop. Or we can simply say in this case electron is like this. This is the nucleus. This is electron. So this electron is coming. It has certain kinetic energy. When it reaches this point, it just stop here. So all the energy of this electron will be converted into X-ray photon. Let's try to understand some more important points about production of X-rays. Curve 1 and this one is the second curve. This curve is produced, means these X-rays are produced when we use voltage V1. Then this curve is produced when we use potential difference V2. In question they can ask you which one is greater. So if you look at these values, we can say we have here lambda min. So we have one value of lambda min. We can say this is lambda min 2 and this one is lambda min 1. So lambda min 2 is less than lambda min 1. It simply means that V2 is greater than V1. We can also say the energy of photon, energy of second photon, mean energy of photon in second curve is greater than energy of photon produced by V1. So photon 1, energy of photon. So this photon has high energy, this photon has low energy because the potential difference here is greater than this one. We also need to understand lambda min. This lambda, it has a special name. I have already explained, but let me highlight this point again. Lambda min is also called cut-off value. So we can say this is cut-off wavelength. So lambda min. Sometimes in exam they can simply ask you to calculate cut-off wavelength. If you're not clear with this term, maybe you will find difficult to understand and difficult to answer. And so we can see these actually, this continuous curve, these radiations are called braking radiations, means they are produced when electrons are stopped. We call them braking X-rays, or we can say braking radiations. Braking X-rays means this continuous curve, and these are produced, so this one you can see continuous curve, and this curve is representing breaking X-rays, but you can see some spikes here. So these spikes are produced if coming electrons hit electrons in the target. Let's say hit this electron. If this electron is removed, then electron from the higher energy level will come to fill this empty space. So when this electron will jump from high energy level to lower energy level, this electron will release energy in form of photons. When electrons jumps from high energy level to lower energy level, they release energy in form of X-ray photons. So they release X-ray photon. That's the reason we see these spikes. And these spikes, they represent characteristics X-rays. Characteristics X-rays. So it's important to understand how characteristics X-rays are produced. So this is how they are produced. So when coming electron, they hit electrons in the metal target, they remove electron from the atom. So the electron from higher energy level, they will jump downwards to fill that gap. And when they jump from high energy level to lower energy level, they will release energy in form of X-rays. In form of X-ray photon. For part, the graph is given between ln I over I naught and X. First of all, let's try to write down the equation for this graph. In this case, we can simply write down I is equal to I naught e to the power of negative mu x. This is the standard equation we have. Now, if we rearrange this one, we can write down I over I naught. This will be equal to e to the power of negative mu x. If we take ln on both sides, we can say I over I naught. This is equal to ln of e to the power of negative mu x. And this one we can write down negative mu x times ln e. And ln e is equal to 1. Value of ln e is equal to 1. So we can simplify. We can write down ln of I over I naught. This is equal to negative mu x. But now if we compare this one with straight line equation, means y is equal to mx. So in this case, gradient is equal to negative mu. And this is the point we need. And we will answer next question. So in this case, gradient of this graph is equal to negative mu. Very important point. We will need this one for next question. Let's move on to question. For part B1, we need to determine the linear attenuation coefficient mu for this beam of X-rays in the tissue. Means we need to find out value of mu. But we have already discussed that gradient of this graph is equal to negative mu. Or simply we can say mu is equal to negative of gradient. Now simply we need to find out gradient. If we take 2 points, we take this 1 point and this point, we can calculate value of gradient. So in this case, the gradient is negative because y is negative. So here we have negative 2.28 minus 0 divided by x is positive because this is x, this is positive. We have 11 minus 0 here. And now if we simplify this negative will be cancelled with negative. So we left with 2.28 divided by 11. So our final answer is going to be 0.207 per centimeters because 11, this has unit in centimeters. So our answer is per centimeters. We can write down this one up to 2SF. So answer will be 0.21 per centimeters. So our final answer is 0.21 per centimeter. For the second part, we need to determine the thickness of tissue that the X-ray beam must pass through so that intensity of the beam is reduced to 5% of its initial value. Let's try to understand what question is asking us. Imagine that we have this tissue. So this is tissue. Question is simply asking us, we need to find out the thickness of this tissue so that intensity of X-ray beam become 5%. Imagine that this is intensity. We have on y-axis and we have x, this is thickness on x-axis. We need to find out when intensity I naught, let's say the initial intensity of X-rays is I naught, when they pass through the body, the intensity will decrease. We need to find out when when the intensity become 5%, that value of x we need to find out. I mean, this value of x we need to find out. Let's say this is x1. We need to find out value of x1. And this intensity become 5%, means 0.05 times I naught. And this is equal to 5%. Let's try to find out value of x1. But we have already discussed that ln of I over I naught, this is equal to negative mu times x. In this case, we said x is equal to x1, so we will use x1 here. But value of I over I naught is given to us. It is given to us reduced to intensity reduced to 5%. It simply means that I over I naught, this is equal to 5 over 100 is equal to 5 over 100. Now we can simply replace I over I naught with 5 over 100, or simply we can say this is equal to 0.05 I naught. Now simply we need to plug in values, so we can say ln of 0.05. So we can delete actually this I naught from here. So this I naught here. We are writing I over I naught. So I over I naught is equal to 0.05. And this is equal to negative mu. But value of mu we have calculated. That was equal to 0.207 times x1. From here we can calculate value of x1. x1 will be equal to 14.7 centimeters, because this is in centimeters. So this is our final answer. This is how you can calculate value of thickness. Now let me highlight one point. Here we have 2. If it was pi, then I over I naught has to be equal to 95 by 100. Reduced by 5% mean 95% is remaining. So we can say 95% is remaining. So you need to understand in the question, is it reduced to or is it reduced by? So you need to be clear about this. That's all what you need to understand about this question. I try to explain you some very important points about X-rays. I hope those points are clear to you. If you have any question, just leave your questions in comment section and I will be answering as soon as possible.